Hello and welcome to Module 7 of the Temporary Chair Training. I am Seth Cohen. You heard me in the previous section, and in Module 7, we are going to be talking a lot more in depth about the various scenarios there are with caucus math. So first, so you understand what we're going to be talking about in this section, we want you to have a more in-depth knowledge of and familiarize yourself with calculating viability. We want you to understand the delegate allocation formula and to learn the different rules of rounding and showing you some scenarios of different things that can happen on caucus night. So that way you're prepared and we can run as smooth as a caucus as possible when we are awarding delegates to the viable groups. So first, viability is based on the total number of caucus attendees, and the viability threshold is going to be determined by the number of delegates that each precinct is electing. And so it will show you the formula again in a second, but those are the two main numbers that you'll be using to determine viability. And as I said in the previous section, we always will round up, no matter how small the fraction of the whole number is, you will round up to the next whole number. So if your caucus is going to be electing one delegate, as I said in the last section, you will have a section that is specific to the temporary chairs that are going to be electing one delegate, because this scenario is a little bit different than the rest. But these bullet points give you a little bit of an idea of what we're going to be talking about. So delegates are going to be elected from the caucus as a whole. Nominations are taken from the floor. The nominee must receive more than 50% of the votes to win, and the nominee with the most votes over 50% wins. With a 2-delegate precinct, you will multiply the total number of caucus attendees by 0.25. So in this example, if you have 40 attendees, your viability would be 10. In example number 2, if you had 453 attendees, you would actually round up to 114 for your viability. So any preference group would need 114 people to secure at least one delegate in your precinct. With a 3-delegate precinct, as we cited, is 16.66%. The easiest way to do this math is to divide by 6 instead of multiplying by 16.66, just less numbers to push on the calculator and it'll get you the same results. So in example 1, you would have 40 attendees, which would get you 6.6 repeating, and you would have to round up to 7 for your viability. In example number 2 here, again with 453 attendees, you would divide by 6 and you would have to round up to 76 for your viability. And for most of you, with 15% being the viability threshold, if you had 40 attendees, you would have 6 as your viability, and with 453 attendees, you would need to round up to 68 to get your viability for that precinct. If you have any questions, you can always reach out to us. If you want to run through some different scenarios that may have happened in the past, you can use these numbers to figure out what the viability would be in various scenarios. So when allocating delegates, it's going to be, as we've talked about before, is going to be based on the total number of delegates to elect to the precinct, the number of people in the preference group, and the total number of attendees that showed up at the caucus that night. This year, we are going to be implementing a statewide rule where we are asking you to round out to 4 decimal places. We're doing this because we believe that in past years, there has been some discrepancies or variation on how people chose to round. So we are just setting this standard statewide that you should round out to 4 decimal places, and this should help limit any weird scenarios where you're not exactly sure if there's a tie or who's supposed to get an extra delegate. This will allow everyone to clearly see the numbers to make that decision. So for example, 1.4999 does not round up to 1.5. However, in this example, as you can see, 1.49929 would round up to 1.4993. Now, sometimes you'll get a number that does not have 4 decimal places. So if you were to get 1.49, let's just say, you would add 2 zeros to the end of your decimal, because that's essentially what it is, and that would get you your 4 decimal places. So all your numbers are going to look the same as you are comparing to see if there are any delegates to be gained or lost from rounding. You should remember that going back to our 3rd grade math, as I somewhat joked in the last section, when you're calculating delegate allotment, you should always round up if the number is greater than equal to 0.5, and you will round down if it is less than 0.5. On to the next section. Again, here is the formula, so you can see it written out. You would take the number of people in your preference group, you would multiply it by the number of delegates your precinct is electing, and then divide it by the total number of caucus attendees. I will pause here for a second so you can write this down if you didn't get a chance to do it in the last section, and then we'll move on. Calculating delegate allotment. So in this example, if you have there are 4 viable preference groups in this caucus of 65 people, that's going to elect 9 delegates. So Group A has 25, Group B has 16 members, Group C has 13, and Group D has 11 members. And then here below, you'll see the delegate allocation formula written out. If you want to practice to make sure you get the same numbers, you can do that. I would just recommend pausing this video, and you can see the results here as Group A has 3.4611 delegates, which would round down to 3 delegates. Group B has 2.2134 delegates, which would round down to 2 delegates. Group C has 1.8121, which would round up to 2 delegates. And Group D would round down to 1.524, or sorry, it has 1.5243 and would round up to 2 delegates. And that, if you add those numbers together, gets you to your 9 delegates, and those are your viable groups and the delegate allotment for each preference group. Now we're going to move into some what if scenarios. So in this scenario, and this is one that could happen, there are more viable groups than delegates there are to elect. As you know, no precinct can elect more delegates than they are allotted. So if there are more viable groups, we need to have a plan for that. So the smallest group must realign until there are no more delegates to elect. So in this scenario, there are 250 caucus participants electing 4 delegates. And after realignment, as you can see here, there are 5 viable groups, viability being 38. So everyone in this scenario is viable. Now, based on what we just told you, what do you believe, which group do you believe must realign? If you guessed Group A, you would be correct. They have the smallest number of delegates, so everyone in Group A would have to realign to either Groups B, C, D, or E. So now, what if rounding causes too many or too few delegates? So groups can gain or lose delegates depending on the fractions that they have. And so, however, groups may never lose their only delegate. So in this scenario, a group has 65 participants and electing 8 delegates. After realignment, the groups are as follows. So Group A is rounded up to 3, Group B is rounded up to 2, Group C is rounded up to 2, and Group D is rounded up to 2. So this means that there are 9 delegates being awarded here, so someone must lose a delegate. Viability is 10, so all groups are viable. I'll let you take a second to decide which group that you think should have to lose a delegate. So if you guessed Group C, you would be correct. And the reason that they lose their delegate here is because they benefited the most from rounding. being at 1.6000. They were the furthest away from two delegates, from their rounded delegates, and would need to lose their delegate, but only get one delegate out of this caucus. So again, what if rounding causes too many or too few delegates? Again, a group can never lose its only delegate. So here, a caucus has 17 participants with selecting 3 delegates. After the realignment here, the groups are as follows. Group A is rounded up to 2, Group B is rounded up to 1, and Group C is rounded up to 1, meaning they've would be at this point electing 4 delegates, and they can only elect 3. So we'll pause for a second for you to decide which group should lose the delegate. If you guessed Group A, you would be correct, because groups B and C cannot lose their only delegates. So this would be Group A would have 1 delegate, Group B would get 1 delegate, and Group C would get 1 delegate. So again, one more time, if rounding causes too many or too few delegates, and you can never lose your only delegate. In this scenario, this caucus has 189 participants and is electing 6 delegates. After realignment, the groups are as follows. So Group A here would round down to 2 delegates, Group B would round down to 2 delegates, and Group C would round down to 1 delegate, meaning that they would only be electing 5 delegates, and there's 1 more delegate to award out of this precinct. So what would happen here is Group A would gain an additional delegate because they are closest to 2.5. And so they were to the 0.5 mark, and so then they would get the delegate, and they would then round up. So they would get the additional delegate, having Group A at 3, Group B at 2, and Group C at 1. And finally, everyone's favorite scenario that everyone likes to talk about is what happens if there is a tie in the allocation math. A game of chance will determine which group gets the extra delegate. So in this scenario, Group A and B have the same number of members at 2.5 and are rounded out. They would round out to 3, meaning that too many delegates are to be awarded. There would be a game of chance to decide who gets the extra delegate. And in this case, it'd be a coin toss, and whoever wins the coin toss would get the extra delegate, and it would be 3-2 in this scenario, whoever wins. And this concludes our section on caucus math. If you have any questions, please make sure to reach out to your county party chair or your district organizer, and we look forward to seeing you in the next section.